Alright, let's look at 3.7. This section is about similar triangles, being able to calculate missing side lengths. There's also a little part that's kind of definitional. Basically, we know things are similar, meaning that they look the same, but they might be different sizes. So you can see in number 1 here, these triangles look to be the same thing, but ABC is just a smaller version of DEF. And the way we know things are similar, or they look a lot alike, just different sizes, are these 3 postulates, or theorems. So AA means all I'm given are 2 angles. So if I know 2 angles are the same on my 2 triangles, then I can say by AA, then they are congruent. If I know that all 3 sides are similar, they have the same ratio, then I can say that they are similar. And if I know that 2 sides are similar and the angle between is the same, then I can say that my triangles are similar. So you're looking for these 3. There's no other theorems that should work for this section. So what does this mean? If I look at number 1 here, I see 30, it matches with 30. 25 matches with 25. Those are 2 angles. They match each other. This is what an AA would look like. I know those triangles are similar. I can set up ratios from those triangles. My next one, I see 2 and 4. So 2 times, right, a 2 would give me 4. And then I see the same ratio here, 3 times 2 would give me that 6. Since that ratio is the same, those sides are similar. And then I can also look at the angle. Well, it's the same, so that would be a side, an angle, and another side. So by SAS. So you're looking for basically an angle sandwich. And my last one, all of these have the same ratio. 2 times 5 gives me 10. 5 times 5 gives me 25. 4 times 5 gives me 20. So if I did 5 times triangle ABC, it would turn into DEF. So all of my sides are known here. That's what these theorems are. You pretty much just have definitional questions. Try to look at the pictures and see what they give you. For the next ones, we're going to be finding length. What I would recommend to do with length is do your small side over your big side. What does that look like? Well, I'm given a 7 here, that's small, 14's big. So I'm going to do 7 over 14. Pretty straightforward. I label it the same in my other triangle. X is clearly my small side, and 42 is my big side. So I'm going to do my X on top over my 42 on bottom. From here, this is a cross multiplication problem. If you remember kind of that butterfly method that you might have done in maybe middle school or even in Algebra 1, cross multiply. So I'm going to do 7 times 42. That gives me 294 equal to 14x. From here, it's a one-step equation. We're just going to divide out that 14. And that gives me x equal to 21. So you just stay consistent. All of these we can do the same exact thing. We're just going to look at our sides. I have 6 and 10. Keeping with my order, I want to do the small side over the big side. So 6 over 10 is going to equal, well, 9 looks to be my small side and x looks to be my big side. So I'm going to do 9 over x. And we're going to cross multiply here, right? We have 6x equal to 9 times 10, which is 90. and we want to divide to get our final answer. So these should be fairly simple. I don't think they have anything too complicated with extra numbers, like x plus 1 or something. We'll see. But I think it's pretty straightforward. And I get x equal to 15. Weirdly enough, 6 may be the hardest one because they give us more information than we need. So what's important here is we want to find x. And I guess the question would be, what side matches with that x, right? So it looks to me that x matches with the 5 over here. They're kind of that middle length side. From there, I can choose to do either of the other ones. So I might do 4 and 20 just to keep them small. So 4 is my small. I'm going to ignore this last side. And 5 is my big here. So 4 over 5 will equal, again, my small is the 20, and x looks to be my bigger side. So I'm going to get 20 over x. And then we got some cross multiplication to do. 5 times 20 is 100, and we get 4x. Divide by 4, and x will end up equaling 25. So if you have all 3 sides given to you, just pick the sides that you really don't want to use. You only need 2. And this is more of the same type of problem. So again, I like small, big, small, big. 8 over 12 is going to equal 10 over x. Cross multiply, I get 120 and 8x. And 120 divided by 8 is 15. Again, visually, it looks like 5 is my small, 7 is my big. And the same things happening. Yes, I'm sorry. The same thing's happening here. 14 is my big and x is my small. So we could set up 14 over x. Or I'm sorry, I'm doing small over big, aren't I? We could do x over 14 equals 5 over 7. It really doesn't matter. I like to do small over big, but you have to stay consistent. So I couldn't do x over 14 and then 7 over 5. You have to be very organized with it. So if you're like me, just stick with small over big and it should stay fine for you. We're going to do 14 times 5, which is 70. And 7 times x, divide out our 7, and x equals 10. Last couple, let's see, x looks to be the big one here, and 32 appears to be small. 15 is bigger than 10. So 32 over x is going to equal 10 over 15. Cross multiply. We're going to do 32 times my 15, which gives me 480 equal to 10 times x. And we're going to divide out our 10. And we get an answer of x equals 48. Last one is another one where we have multiple options here. What I would personally do, I see a decimal here. I don't really want to work with that decimal. That 13.5 looks to be my smallest side. So I'm going to cross out this 9 over here. That's just personal. If I see a decimal that I don't want to have to deal with, get rid of it. Okay? It looks like 10 is my small side, and 12 is my big side. 18 is my big side, and x is my small side. X over 18 will equal 10 over 12. Cross multiply, I get 180, the best number in geometry, equals x times 12. And then we're going to do 180 divided by 12, which gives us an answer of 15. This section really liked the answer of 15. But you're basically just setting up cross multiplication is the goal here. I'll see you guys in class.